All right. So we look at the derivative of the inverse hyperbolic functions, and what we look at here is the hyperbolic inverse. Uh, the hyperbolic inverse, where we say in this case we use a hyperbolic cotangent inverse of x. So if we say y is equals to hyperbolic cotangent inverse of x, we are going to say our x is equals to our hyperbolic cotangent of y. So differentiating both sides with respect to y, you are going to get your dx dy being equals to minus hyperbolic cos squared of what, of y. All right, so writing the expression for dy dx will be equals to minus half of minus 1 over 2. I mean minus, yeah, minus 1 over 2. We are multiplying by 1 over the hyperbolic cosec squared of y. So here we have what, hyperbolic cosec squared of y, like that. So what we want to do is to find out what the hyperbolic cosec squared of y is. So we get this from the identities. Okay, so we are told that hyperbolic cotangent of x, okay, but in this case I'll use y, minus hyperbolic cosecant squared of y is equals to 1. So making this the subject of the formula, you're going to say your hyperbolic cosec of y is equals to uh, root of cotangent, okay, cotangent. But in this case, I don't really think we need the root there, because when you look at the denominator here, it's in terms of squared. So we're just going to say our hyperbolic cosec squared of y is equals to our hyperbolic cotangent squared of y minus 1. So writing the dy dx expression, you're going to say dy dx will be equals to minus 1 over, okay, 1 over hyperbolic cotangent squared of y minus what, minus 1. And if you want here, you can try to do something with the negative there, so meaning your dy dx will be equals to 1 over instead of us saying hyperbolic cotangent squared of y, we're going to say 1 minus hyperbolic cotangent squared of what, squared of y. So this is 1 over, remember to say what our hyperbolic cotangent is equals to what, x. So this is 1 minus um, this will be equals to 1 minus x squared, like that. So as always, always keep in mind our dy dx will be equals to our 1 there just indicates our u prime, or our f of prime, f prime of f of x, or f prime of x, okay, f prime of x there. So meaning on the denominator you have 1 minus u squared, and that is simply the expression. So you can try to replace our u with anything. Our u here, we just have to use it for to in place of what, in place of x there. So this can be 2x, and that can be anything. So it basically means here you don't have to go through all these steps that I've gone through. If you're given to say they are looking for, if you are looking for, let's say um, y is equals to hyperbolic cotangent inverse of 2x, so you just have to use what, that formula there. You're going to say your dy dx will be equals to u prime, this is our u right here, which is simply a squared there, not a squared but 2, which is equals to a 2 there, divided by 1 minus you have what, 4 squared. You have a 4 squared there. So that's all in this video. That's how you go about finding that. Thank you very much for watching.